Hello, everyone. Welcome at the fifth CHI talk organized by the CHI software team. Here we gather to discuss all things related to the IT industry, the software development process itself, sales processes, marketing, and other activities. Today, in particular, we are focusing on the technical side of things, namely text simplification, which is a part of the natural language processing niche, or NLP. NLP and AI in general are our expertise areas, and we like both discussing it and then implementing it in practice. Now, before I get further, let me spend just 1 minute, as usual, on a very special advertisement. Last year, our developers created a mobile app called Be With UA, with the goal to help everyone who defends Ukraine at the front. This app is available for both iOS and Android users and surprisingly does not require any donations from you, just some of your free time. So if you feel you want to help, please feel free to follow the links provided in the comments section or use a QR code you now see on your screen. Now, let's get back to the main topic of our conversation, to text simplification. Our goal for today is to overview the general process of text simplification based on examples, also overview the tasks that text simplification can solve and possible prospects it has. The expert of today's event is Olha Kanishcheva. She's a researcher at Jena University in Germany, and also a consulting ML NLP engineer at CHI Software. Olga has more than 10 years of experience in the NLP niche, and we are very grateful to have her here today. Also, if you feel you want to ask any question related to text simplification, please do it by sharing it in the comments section. We'll get back to your question by the end of our event at the dedicated Q&A session. So don't hesitate to ask. Without further ado, this is it for my intro part. Olga, you're welcome to start your lecture.
Thank you, Polina. Okay, so hello. Thank you for the opportunity to be here today. So my topic is text simplification, progress, tasks, and perspectives. Polina said some words about me, but maybe I repeat. Yeah. So I'm a researcher at University of Jena and a consulting ML NLP engineer at CHI Software. I have a PhD degree in computer science and more than 30 scientific publications in the NLP area. Also, I am a participant in many international projects, ACAMIN, Mastis, COST, etc. Usually, it is a European project and related with NLP. Also, I have a practical experience, more than 7 years, on real-life project. And I'm a member of the special interesting group on Slavic natural language processing and organizer an international conference, computational linguistics and intelligence systems. So, what is a text simplification? The text simplification is not new, the task of text simplification, but quite challenging. The main goal of text simplification is to make complex text accessible to a wide audience by increasing its readability. Automatic text simplification reduces linguistic complexity So the text has to be more understandable and readable, but the main idea is saved. Text simplification can be used such as subtask for the machine translation, question generation, information extraction, spelling correction, and fact retrieval. But or for the separate task for the creation of simplify resources. Automatic simplification helps people with the low literature levels, such as children and non-native speakers. In addition to that, people suffer from different kinds of reading comprehensions, autism, aphasia, and dyslexia. Um, Text simplification is divided usually into two tasks, lexical simplification and syntactic simplification. Sometimes you can meet the third category, discourse simplification. Lexical simplification identifies and replaces complex words with the simpler synonyms. Syntactic simplification tries to simplify the grammatical complexity by identifying complicated syntactic structures such as coordination, subordination, relative clauses, and passive relative clauses, which may be difficult to read and or understand. So sometimes very often, people ask me, how defined is word simple or not? If we don't know anything about the text simplification, I put on the slide some example. As for me, such word, yes, clamor, alacrity, largest. So these words are not very common for the people which are not native speaker in English, yeah, but a native speaker can use, or you can meet these words in different documents, on the TV, etc. And the general lexical simplification pipeline has a following view. I need to say that it was very popular approach before large language model. Yeah, so we try on the first step we try to identify the complex word. For example, on this slide you can see the sentence: the cat patched on the mat, and we found that this word patched is complex, and we tried to find different synonyms for this word. For this task, use different approaches from the machine learning, word embeddings, etc. And we found some list of words: rested, sat, roosted, settled. After this, we ranking these words by frequency and found that set is a more popular word for the patched. So, such as output, we receive the new sentence: the cat sat on the mat. So we simplify this sentence, but it's only lexical simplification. On this slide, you can see other example. This example from the materials of deep learning for text simplification. You can see original sentence: deputies arrived at the house several minutes later to hear more shots fired. And simplify, yeah, deputies came at the house several minutes later to hear more shots fired. So the word arrived was replaced by word came. Yeah, so because came is more popular than arrive, so it's other lexical level. If we say about the syntactic simplification, it's more interesting as for me, and you can see two different examples. First example, we have a sentence: Mr. Antoni, who runs an employment agency, decries program trading, but he isn't sure it should be strictly regulated. And this sentence was split into three separate sentences. Mr. Antoni decries program trading, Mr. Antoni runs an employment agency, but he's not sure it should be strictly regulated. So the second sentence, also very long, contains a lot of simple sentence inside. And a simplified sentence contains two separate sentences. So for the syntactic simplification, we usually works with the syntactic trees. It's the output of syntactic parsing, and we try to simplify this tree and receive simple sentences which contains object, verb, and subject. So the main such triplet. And sometimes we need content reduction. I want to say that in this presentation, I prepared some examples in English or in Ukraine, and also in Ukrainian. On this slide, you can see such example from the real data set. We have input sentence. Ланцюг островів становить частину Гебридських островів, відокремлених від материкової частини Шотландії та внутрішніх Гебридських островів бурхливими водами річок Мінч, Малий Мінч та Гебридського моря. And the output after simplification model, we receive such sentence. Ланцюг островів є частиною Гебридських островів і відокремлений від материкової частини Шотландії кількома різними водоймами. So, you can see on this example that we have reduct the initial sentence maybe on 50%. We remove property nouns, different locations, but we can save the main sense of the initial sentence. The next slide. On this slide, you can see possible obstacles which can be met in the text simplification. Of course, it's only one part of them. It's metaphors and idioms and sarcasms. It's I think it's a high level of natural language processing, if you can process in such linguistics features. The next is semantic ambiguous words and phrases, if we have words with a lot of meanings, and technical words and phrases, because if we say about the general text, everything is okay. If we need to simplify, if we say about some documentations, medical documents, or maybe text related with the electricity, such text contains a lot of technical terms, and many people could not understand what does it mean. So we need to add definition, or we need to find synonyms if these words have such synonyms. And other structure complexity, it's a morphological, orthographical, and phonetic complex words, and also syntactic complex sentences. On this slide, I put some examples idioms and metaphors in English and in Ukrainian. In English, for example, the news you bring me is a dagger to my heart, and these thoughts melted away, or butterflies in my stomach. So it's such cases are very difficult, first of all, to identify, and the next step to simplify. And some Ukrainian examples Час біжить, байдики бити, що кіт наплакав, ось тут собака зарита. So all native speakers understand these phrases, but it's very difficult for children, for example, yeah, for small children, for non-native speakers, etc. So the simplified text should be understandable. It's not always clear how to do this. On the slide, you can see some rules have been devoted that make the text more readable. This is only general rules, and maybe it can be useful for you. But it's first of all, you need to use of simple, straightforward language, only one main idea per sentence, the evidence of technical language abbreviations and initials, a clear and logical structure. Similar rules you can find on such resource as Simple Wiki. Maybe you know about this resource, maybe not, but it's very useful. It's a parallel resource to Wikipedia. Yeah, but it's Simple Wiki. So all articles were created by Simple English. And on this on the slide and also on these resources, you can find some recommendations how to write simple articles. What does it mean, simple text? Yeah, so you need to use basic English words, short sentences. Use the page to learn and teach. Simple does not mean short. So you can write longer, but using short sentences, etc. And an example, on the left you can see article from the Wikipedia about the Great Britain, and on the right, no, from Simple Wikipedia, and from the right you can see the example of article from the Wikipedia. And of course we don't want to read all article, but if you look on the slide, you can see that article from the Simple Wikipedia does not contain numbers, brackets, links on the extra resources. It's short sentences without does not contain words such noun plus noun. For example, ninth largest. Yeah, so all sentences are very short and clear. So it's the main idea. Simple Wiki is the first, I think, the first main resource for the text simplification task, because we have parallel corpora for the text simplification. From one side, we have original Wikipedia articles, and from the other side, we have such articles by in Simple English. These Simple Wiki rules in more details, I put this, but if you're interested, you can find on this site of Simple Wiki these rules. But you can see that don't use idiomatic jargons, so abbreviations, change to active voice, passive voice, about grammar, etc., in more details. For any task related to machine translation, we always talk about the data at the beginning. Yes, because data, it's I think it's one of the important part for each task now. Now consider the most popular data sets to simplify the text. Yeah, you can see the original link on this slide or on the site. You can find a full list of text simplification datasets, but the most popular is Tour Corpus, Newsella, and Asset, and Wikipedia, of course. So Tour corpus. Tour corpus is a data set with 2,359 original sentences from English Wikipedia, each with the 8 manual reference simplifications. And the full data set is divided into two subsets, 2,000 sentences for validation and 359 for testing of sentence simplification models. Other source is Newsella. Newsella is a company. They create a software for the education, and they also create data set for their research and task. And this data set is closed, but you can receive this data if you fill official form on their slide, fill your name, position, why you need this data set, etc., because it closed for the commercial task, but open for the research. And the last data set is the asset corpus. It's corpus from Facebook. It also contains more than 2,000 sentences and split into data sets, 2,000 sentences for the validation and 359 sentences for the testing. So for the Ukrainian language, we create the analog of this corpus, asset tukur. We translate the asset dataset into Ukrainian and manually check all sentences. For the translation, we used Helsinki NLP model. It's a quite good model, but of course, we need to check because some sentences after translation are not nature. Yeah, it's an artificial Ukrainian language. So, so we need to check manually. On the slide, you can see example from the original asset data set and the asset tukur. Yeah, some examples. The main problem was the translation of proper names, because some of this, some of companies, locations, yeah, name of the cities. We know how translate these words, but some of these unknown. If we don't know how to translate this proper name, or we state without translation. A lot of questions arise with this data set, because if it's so easy translate one resource to other, I think a lot of resources will create it such way. Yeah, but you need to understand that when we translate from English to Ukraine, we lose some nature features of our language, Ukrainian. But I think for this task, for the evaluation of text simplification or pre-training model, we can use this data set. And we realize some experiments with the coefficient of syntactic complexity and analyze this coefficient for the different subsets, for the original text and valid and the simplified text valid, and the original text test and the simplified text test, and receive that the value of this coefficient is corresponding, yeah, to the complexity of this text. So if this value is higher, it's a difficult text. It's a low, less, so it's less difficult. So this coefficient show that everything is okay. Some words about the evaluation. As a general evaluation of text automatical simplification system, we can present in such diagram. Yeah. So the first, it's we try to analyze effectiveness and usefulness. And other branch is the quality of the output. Uh, for this branch, you usually use automatic evaluation metrics and human evaluation. Of course, a lot of people use only automatic evaluation because it's cheaper and you don't need a lot of money for the human evaluator. Automatic evaluation contains readability measures. There are a lot of different coefficients for the evaluation of text simplification, but in my opinion, it's not good for the other languages because it depends on the language and domain. It's very important. And other approach, it's machine translation evaluation metrics, but not only machine translation. There are some metrics were created especially for the text simplification evaluation. Human evaluation, it's a very high quality of evaluation. You need time, money, but you can analyze grammatical correction, meaning preservation, and simplicity. So it's a separate branch and a very big work. So there are the most popular evaluation metrics are shown on this slide. So it's BLO, SARI, SAMSA, and BERT score. Some word about the blur. I think many of you know this score because this is a measure comes from the machine translation. Yeah, so blur score was traditionally used for the evaluate machine translation. This matrix is used for the text summarization, image caption, and machine translation, speech recognition, and this matrix uses n-grams, different n-grams, and you need to find ratio between number of correct predictive n-grams and number of total predicted n-grams. On the slide, you can see the example for the 1 gram. Yeah. The next slide show the example for b-grams. And the final formula is presented on this slide. For example, BLOT2 uses a geometric average of unigram and bigram precision. Yes, so it's not so difficult, and you can use special library for the evaluation of text simplification, and this library usually contains these metrics. But BLOR has some restrictions. It does not consider the meaning of words. So if you have two different words, but these words are synonyms, metrics could not help with this situation. It looks only for the extract word matches. So if you have talk and talking, or raining, it's also not important for the BLOR. BLOR ignores the importance of words. So if it's noun or article, for the BLOR, it's equal words. And it does not consider the order of words. So the sentence, the guard arrived later because of the rain, and the rain arrived later because of the guard. It's different sentences. The next measure is a SARI. SARI is the metric used for the evaluating automatic text simplification system. So this metrics especially for the simplification. The metrics compares the predicted simplified sentences against the reference and the source sentences. It explicitly measures the goodness of words that are added, deleted, and kept by the system. And these metrics are very good for the evaluation of lexical paraphrasing. The next metrics are SAMSA. SAMSA is the evaluation metrics and human evaluation benchmark for the text simplification. What does it mean? Yeah, and this sentence could show the quality of sentence splitting. Yeah, and to calculate the SAMSA metric, you would typical to follow the following steps. Yeah, prepare a set of reference simplified text. This text should be written by humans and serve as a gold standard for the simplicity. The next step, generate simplified text that you want to evaluate. Align the general simplified text with the reference simplified text at the sentence level, and perform semantic analysis on each candidate reference pair. This involves analyzing the semantic similarity between the candidate and the reference sentences. Calculate the SAMSA metrics by aggregating the semantic similarity score obtained from the previous step. So it's also very popular metric. And the last, it's the best metric for the text simplification now, and also the most popular, is BERT score. BERT score leverages the pre-trained contextual embedding from the BERT model and much words in candidate and reference sentences by cosine similarity. So it's not so difficult, but it works very good. It has been shown the correlative between human judgment on sentence by system level evaluation. You can find a lot of works related with these metrics on the Hugging Face, on special papers which related with these metrics. Okay, so when we say about the building automatic text simplification systems, we need to understand that such system contains three models. It's not separate models. Now it can be one model or model and post-processing. It depends on your application or your domain, but it's a lexical simplify, syntactic simplify, content reduction, and adding information definitions. So adding information, it's I said before that if your text contains a lot of abbreviations, maybe special words, terms, etc., you could not find good synonyms for these terms, and you need to put definitions in the text. And these definitions help people to better understand what does it mean. Yes, it's interesting. It's a new word for him, and they need to clear understand what does it mean. Okay, and about text simplification models. So on this slide, you can see some of the most popular models for the text simplification. Yes, so all these models based on the transformer architecture. It's a BART, T5, MBART, MT5, and the last category, it's not separate model, it's a large language models. So because now maybe the last 6 months or 8 months, yeah, we cannot keep up with the news about the language large models. Yeah, on this week we receive new GPT model, on the next free and also good model Llama, and the next it's for example model from the Facebook, from the Google, from the Meta, etc., 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 and each of these model has advantages and disadvantages. Okay, so the most popular for the text simplification, one of the most popular is a BART. On the slide, you can see some experiments with the BART model. These experiments with the very popular benchmark for the different tasks. And BART is a denoising autoencoder for pre-training sequence-to-sequence model. And very often people use this model for the text simplification. Also, we have MBART model. MBART is a multilingual sequence-to-sequence model based on BART, training as a denoiser autoencoder and using random span masking and sentence shuffling on a subsets of the 25 different languages from the XML-R dataset. So BART model can be used for other languages. You can pre-train this model for your languages, and you receive better result. So you, and it's I need to mention that such models don't need a lot of data for the pre-training now. So the next model is a T5. It's also very popular, and T5 stands for the text-to-text transfer transformer. It was released by Google on 2020 as so it's an old model now, we can say. As the name suggests, it's a transformer-based encoder-decoder model used for the text generation. And in contrast to the other famous transformer-based model like BERT or GPT, which is made up of either the encoder or decoder part of the transformer, T5, using the complete encoder-decoder architecture, is better than only using decoder. So it's also very popular, and but only for the English. Now it's a model T5, and we have a multi-language T5 model. And also on the slide you can see some experiments with different models and their different benchmarks. You can see that MT5 model shows not so bad result as a big model. Yeah. Okay, but when you train your model for the text simplification, very often people use control tokens. For the text simplification, it's such tokens, the ratio between the length of the source and the target sentences, where the length is expressed in characters. The next, it's a normalized character level Levenstein similarity between the source and larger sentences. The third ratio between the word rank of the target and source sentences, where the word rank stands for the inverse frequency order of all words in a sentence. And the last is the ratio between the maximum depth of the dependence tree of the source and the target. So it's these tokens very useful for the text simplification when you create your own model. On this slide, I present the results, some experiments with the T5 model for the text simplification. In the first table, you can see how works T5 base model for the lexical, for the splitting, removing, adding, etc. And the last table, the second, contains authors of this publication use T5 model and train this model for the 3 different data sets related with the wiki, and they present their results using blur, SAR, different readability formulas in their paper. So you can find more results on this link, but these models showed very similar results. Yeah, and sometimes you can see that lexical simplification for one model is more better than syntactic simplification, because you need to analyze different features of this model. Yeah. So this result of different models based on transformer for the different for two data sets, asset and tool corpus, and the both numbers is the best value for different models. So T5 base shows very good results. And of course, I could not say about the GPT, because I think a lot of people now use GPT for different tasks, for the answer question, for the motivation letters, for the master degree and bachelor diploma, etc. So it's only one example. Of course, we don't have a lot of time, but we have such a sentence. In return, Rose wore fealty to Charles, converted to Christianity, and undertook to defend the northern region of France against the incursions of other Viking groups. It's an original sentence, and it's my opinion, but it's sentence rather difficult. After two iteration, GPT creates such simple sentence, and I think it's sentence very good sentence. In return, Rollo promised to be loyal to Charles, adopted Christianity, and agreed to protect northern France from other Viking attacks. So, I highlighted in different colors which words or phrases were replaced. So, swore fealty, promised to be loyal. So, promised to be loyal is rather simply, yeah. Converted into adopted, undertook into agreed, defend into protect, and the phrase against the incursions was deleted. So, of course, if we ask human to prepare simply a sentence, of course, each of us create other sentence, yeah, and maybe use special words, yeah. It depends on your English level, but for if we say about the mathematical simplification, it's a very good result. But of course, sometimes it does not work good for the English, yeah. But we say also for the only for the English now, because for the other languages, such model, unfortunately, now works not so good. What about the useful resources? If you're interested in text simplification, you can find a lot of information on the Hugging Face site. You can find about the models information, models, different data sets, metrics with a short description. Yeah, and of course, you can find not all, of course, because now we need to collect data from different resources. It's a site, nlpprogress.com, English simplification.html. This site contains basic information about the text simplification, but this site contains a lot of links on external resources, and you can find more information if you want. So what I need to do also about the using large language models. The main function of such models is summarization of knowledge, answer question, yeah, but summarization is the most important. So for such task as simplification, sometimes it does not work so good, because we need to, from one side, we need to save the main idea, but this main idea must be created, yeah, it must be created using simple English language, and sometimes such model could not understand what does it mean, yeah. So thank you for your attention. I'm ready for the questions.
Okay, that's great. Thank you, Olha, for such an insightful presentation. To me personally, each time it's a huge revelation to listen to something. I don't know. It's really amazing that people now can approach such interesting technologies, because I'm not a tech savvy person, like to a high degree, right? But
Mhm.
in any case, like just seeing the examples of text simplification and the fact that it all can be done with technologies, that's so cool. So thank you. Yeah, that's right. It's time for our Q&A session. Please feel free to ask your questions, because this way we'll make this presentation like the most beneficial for you, like our listener, personally, right? So okay, we have like a lot of questions from one of our listeners. Let's try to display them on the screen. Oh, yeah, cool. It can be
Mhm.
displayed. Uh, okay, the following questions. As I understand, the TS data sets are based on sentence to sentence simplification. Are there any data sets that perform one sentence, many sentences simplification? Kind of the reverse sentence fusion, as was shown on the slide with the SAMSA metric. Um, I think that we should answer this and then
Yes,
proceed to
I
other
think
questions.
yes, this question contains a lot of questions. Yeah, and need to simplify. Thank you, Artem. All these data set which I present in my presentation contains not uh, parallel one sentence to other sentence. So sometimes, for example, a set data set contains one English sentence and corresponding two sentences to simplify sentences. Yeah, so it depends on the data set, and you need to analyze what is if you try to do some experiments, I recommend to use the popular data sets, because you can compare your results with other. But in future, you can use different resources for this task. And this, I hope it's the answer on the first question. Um, about the some symmetric content reduction to the summarization on the level sentence. Um,
Is it related
some
to the summarization?
Yes, yes, yes. Of course, it's. I think tech. It's. I read about this. Yes, text simplification related with text summarization tasks and machine translation, but it's. We need to analyze different features after simplification. So it's the main idea, and these different kind of measures, yeah, sum, sub, blur, sari, try to analyze different kind of simplification. And you could not understand only one side of simplification. You need to analyze and lexical simplification. Yeah, one metrics shows lexical simplification, other syntactic simplification, and you need to analyze in complex. I hope I answer on your question, because I could not see the full the full question.
Okay, I think that Artyom's, yeah, and I believe that Artyom's comment did not fit in. Yeah, the ending. Yes, I believe that the comment section was not enough for Artyom's
Yeah,
question.
it's very long question. Yeah,
I
yeah.
think, Artyom, if you want to continue, like as you can see, we don't see the ending of your message. If you want to add up something, please feel free to add what you would like to ask. Yeah. Okay. So Artyom added like this the following sentence regarding the definition of the complex text. Can the coherence of the text be considered as the metric that correlates with this definition?
Co-reference of the text consider as a metric as a correlation with this definition. Coherence. I think yes. Yes. But difficult text also it's a complex text depends on the domain, not only for the language is one side, domain is the other side. And if we can use, for example, large language model for the general English text, yes, but if you need to work, for example, with the medicine data or with the data related with some, I don't know, maybe energy, yeah, about energy, I recommend to pre-train own model we adopted to your domain. So complex word, it's rather quite term, and depends on the domain, because a lot of uh, works related with the simplification text for the pupils, for example. Yeah, we have a lot of, it's a really problem for the Ukraine now, when we have if you have children and they study at school, you can read his student book and understood that it's not simple text for these students, yeah, for these pupils. So you need to analyze the level of this pupils, and you need to additional features and additional restricts on the text. So I think yes, but not, it's not so not only this, from this side you can analyze complex text. It's a really difficult and complex definition.
Okay, thank you. Now, regarding the question that interests me personally, I researched that the NLP market is expected to grow nearly 14 times bigger in 2025 than it was in 2017. In your opinion, what do you think impacts such growth the most?
I think it will be related with the growth of large language models such as GPT, Llama, etc. Because these models open a lot of opportunities for the development or new applications. Yeah, so you don't need a lot of knowledge in machine learning, but you need only API and clear um, models can adapt your knowledge to the production. Yeah, so I think it's related with this. And the second because each month, each year, we collect a lot of data in text format in different areas, and of course we need to process this data. And I think this two reason of growing such growing of NLP.
Okay, yes, thank you. That's right. That's very interesting what's happening now, like in the AI area, I would say, with the chat GPT innovations. And I personally feel that a lot of industries may change with all the opportunities and capabilities we have now. like really cool. Okay. You also mentioned a lot of models in your presentations that can be used for text simplification, or it is correctly to say to call them text simplification models. Which of them is used most frequently, or maybe which of them is like the most efficient according to your experience?
Um, uh, as I say, the most frequently models are models based on transformers, such as T5 and BART. So you can use these models or similar models or multi-language models based on this architecture for your application.
Okay. And the last question from my side. Um, does the language of the text affect somehow the text simplification workflow? And if yes, in what way?
Yes, a lot of models now were created only for the English language. If we compare how works ChatGPT with English and with Ukrainian, we can find that it's a very different way.
Mhm.
So a lot of mistakes in Ukrainian, some stupid phrases, etc. But for the English, it works very. I think it's rather good, and of course, the language is. The language is influence on this process. So if you need to work with English, it's a one way, yeah. If you need to work with other language, for example, I don't know, maybe Spain or French or Germany, it's other. Of course, for each languages now create a lot of different resources, but not so many as for English. And of if you need a special resource in this domain or in this for this language, and can be problem. But from the other side, this big language models don't need a lot of data for the pre-training. It's a big plus of these approaches. So you need to only few examples, and other models can adapt for your domain and for your language.
Okay. Okay. Thank you, Olga, for answering our questions, my questions, and Artem's. Um, it was indeed very insightful. Thank you. I'm very grateful to our audience as well, who's interested in innovations. Thank you guys for being with us, for listening to the presentation. A small reminder for those maybe who didn't hear it at the beginning, our team of developers created a mobile app, Be With UA, aimed to help Ukrainian defenders with no donations required. If you're interested, just go to the beginning of the comment section. You'll find links there to read more details, or you can use a QR code. Uh, you now see it on the screen. Okay.
Thank you,
Now,
Polina, for the invitation.
yes, yes, that's great. Thank you. I hope to see you at one of our next webinars. Yes, and for now, have a great night. Yes, bye bye.
Thank you. Bye.
Bye, everyone.